Moving into chapter 8, this is section 8.1, and we're going to talk about dilation and scale factor. Oops. So in chapter 2, well, that was a while ago, but in chapter 2 we talked about transformations, and we talked about three kinds of transformations. Does anybody remember what transformations we talked about in chapter 2? Reflection was one of them. Reflection, rotation, and you were close, translation. So we talked about these three transformations. Reflections, like a mirror; rotation, just like it sounds; and translation just means we're moving things around. And we gave these three transformations a special name. We called them the rigid transformations. And we used the rigid transformations to come up with a definition of when shapes were congruent. We said shapes were congruent if one was a rigid transformation of the other. So if we could move one around, reflect it, rotate it, move it around, and it matched up exactly with the other shape. So that's how we defined what we meant by congruent. We're going to talk about a new kind of transformation in chapter 8. Chapter 8, we're talking about dilation. And a dilation is a transformation that changes the size of a figure or an object. So I'll just say changes size, but not shape. And we're going to talk, chapter 8 is all about how we're going to make sure that happens, that we change the size of something and not change its shape. So chapter 8 is all about dilations. So first thing we're going to do is talk about how we dilate a point. Dilating a point is very easy. So to dilate a point, so we have a point with coordinates x, y. So this is our point on our graph. We have point x and y. To dilate a point, all we do is multiply x and y by some number n. And the way we write this, guys, the way we write this is capital D for dilation. The dilation of x and y is n times x and n times y. So this is our new x and this is our new y. And we call n, this number that we multiply by, n is the scale factor. So dilation of a point it's kind of like, and dilations in general it's kind of like talking about maps. So if I'm at a point here on the ground and we have a scale factor of 1 inch equals 1 mile, and there's something that's an inch away from me, or a mile away from me here, on the map it's going to be an inch away from me. So it has to do with how we're changing the size of whatever we're talking about. So let's look at an example of dilating a point. Any questions on what we're talking about so far? Okay. So if we have, the problem might ask you, what is the image of the point 1,3 after a dilation and d, x, and y just tells us that's our dilation equals 3x, 3y. So all this is and what is the scale factor? Our second question is what is the scale factor? Well, all this is telling us is multiply the x coordinate by 3 and multiply the y coordinate by 3. So our dilation d of our point is just 3 times 1 for the x and 3 times 3 for the y. So this is my new x and this is my new y. Well, 3 times 1 is just 3 and 3 times 3 is 9. So that's my dilation. And what's going to be the scale factor here? What do you think, Grace? What do we multiply each number by? 3. So our scale factor is 3. Our scale factor is just whatever the number is that we multiply the x and the y by. So this would be a scale factor of 3.
But how do you know, like, for the D1 or 3, where to get that?
It tells us, this is our rule,
Okay,
so it gives us this rule, and we're going to do that dilation to that point. Okay? And if we graph this, what would happen is, I have this point at, let's say this is 1, 3, and my dilation, I go over 3 and up 9. So my new point is going to be graphed up here. And what the dilation, yes?
Will they always be the same number?
Yes, for a dilation, that's a good question. For a dilation, they always have to be the same number. Because if they were different numbers, then they would be doing something different to the x and to the y. And that would make if we were doing it to a shape, then the shape would change. It would get stretched in a strange way. We want to make sure we do exactly the same thing to the x and the y. So for dilation, it'll always be exactly the same. Okay? It's a good question. And what we would see here is the distance from from 0, 0 to 3, 9 is 3 times the distance from 0, 0 to 1, 3. So the scale factor changed the length of that segment by 3. We're multiplying the length of the segment by 3, by the scale factor. So that's one thing that dilations do, is it multiplies the length by the scale factor. So this is going to be true in any kind of dilation. Dilations multiply length by scale factor. So that's one important thing about dilations. Now we can make things bigger with a dilation, or we can make them smaller. We can make the length bigger, or we can make things smaller. If our dilation makes something bigger, I'm just going to write bigger equals, we call it an expansion. So if we do a dilation that makes something bigger, we call it an expansion. And smaller, guys. If we make it smaller, we call it a contraction. And the scale factor tells us whether we have a dilation, or sorry, an expansion or contraction. If the absolute value of n, our scale factor, is greater than 1, so we have 1, 2, 3, 1.5, 3.5, 5 and 2/8, some number that's bigger than 1. And it can be positive or negative, that's why we have an absolute value there. If our scale factor is bigger than 1, we get an expansion. So back on our last example, we had a scale factor of 3, so it stretched the length by 3. If our absolute value is less than 1, and what this is telling us is that it's a fraction smaller than 1, or a decimal smaller than 1, a fraction or a decimal, we get a contraction. So if our scale factor is a number bigger than 1, positive or negative, we get an expansion. If it's a fraction smaller than 1, we get a contraction. So if we had a scale factor of 1/2, it would shrink our lengths by 1/2. It would divide everything in 2. So dilations are kind of like we would think about them. Just they're relatively they're intuitive. We multiply by a number, we get bigger. We multiply by a fraction, it makes it smaller. So it kind of makes sense of how we would think that they work. Any questions so far? So we can shrink things, we can grow things. Our scale factor tells us whether we make them bigger, whether we make them smaller. And really all we're doing is multiplying lengths by our scale factor. All right, let's talk about how we draw dilations. So I'm going to draw a dilation of a triangle. And I'm not going to write it all out in words, what I'm doing. I'm just going to do this example because it sounds way more complicated than it is. So we're going to start with a point. The point for our dilation is called the center. The center of dilation. So let's do a dilation of this triangle. Let me make it just a little closer to my point so it'll fit on my screen better. So I'm going to do a dilation of this triangle. And for this dilation, we're going to say that the scale factor equals 2. So the problem is saying draw a dilation of this triangle with a scale factor of 2. So what I'm going to do is take my straight edge, ruler, edge of your notebook, something, and I'm going to draw a line from the center of dilation through the vertex and extend past. And I'm going to do that for each vertex. So I just draw a line from the center of dilation through each vertex of the triangle. And if my scale factor were negative, I would draw it, I'll do them in dotted blue lines. If my scale factor were negative, I would go from the vertex through the point in the opposite direction. So if my scale factor were negative, I would go the opposite direction. So this side is -2. Everything's the same except I just draw my segments in the opposite direction. So we can follow the same directions. For a negative scale factor, I just go in the opposite direction. Now what I'm going to do is grab a ruler and I'm going to measure. So I'm going to put my ruler on the center of dilation and I'm going to measure how far, and I'm going to move this over once I get there. I'm going to measure in centimeters just because it makes it a little easier here. I'm going to measure from the center of dilation to this vertex. So it looks to me like that's about 22 millimeters. And I'm going to multiply that by the scale factor. So this is 22 millimeters. And I'm going to multiply that by 2, and I'm going to make a point out here at 44 millimeters. So I'm just multiplying my points, that length, by the scale factor. So this whole segment is 44 centimeters. And I'm going to do that for each vertex. I'm going to set my ruler on this vertex. Need to rotate this down a little bit first. And I'm going to put my ruler there. I'm going to measure in millimeters again. So from the center of dilation to this vertex, I get about 40 millimeters. Multiply that by 2, and I'm going to make my point out here at 80 millimeters. So I'm just multiplying the lengths by the scale factor. And I'm going to do the same thing for this last vertex. Set it down here. Put my ruler there. Move it down so I can measure in millimeters, and it looks to me like that's about 26 millimeters. Multiply that by 2, and I get 52 millimeters. So I'm going to be about there. And now I'm just going to connect those dots. And I'll do that in blue. Make my line solid first. There we go. And there's the dilation of my triangle. And what we would find on this triangle is the lengths of the sides are twice as long as the lengths of the sides of our original. And just a little bit of a vocabulary, we call the original is called the pre-image. And the dilation is called the image. So the smaller triangle is our pre-image, and the bigger triangle is our image. And if we had a scale factor, any other scale factor, I would just multiply the lengths by whatever the scale factor was. If our scale factor were a fraction, say our scale factor were 1/2, I would multiply each of these lengths by 1/2, and my dot, rather than being past the original, past the pre-image, would be here inside where the pre-image was, and I'd have a smaller triangle in here. So my dilation with a scale factor of 1/2 would shrink the lengths by 1/2. And if my scale factor were negative, I would measure this distance, and then I would draw my image over here on this side the opposite way from from my original. Any questions on drawing dilations? We just draw these segments and measure along and multiply the length by the scale factor. Okay, one last thing, and then we're done for today. So let's say we have an image here, or pre-image, sorry. So this is my pre-image.
A line.
It's just just a segment. And here's my center of dilation. And I have a dilation of that line, so I'm going to draw my segments through there. Dilation of that segment. And let's say that my image is right here, and we know the lengths. So this is my image. So this is what I get after I do the dilation. And we know that this is 2 inches tall, and this is 5 inches tall. And we want to know what is the scale factor. So if I do this dilation to this segment, to my pre-image, and I get this image, the original is 2 inches tall, the image is 5 inches tall. How would I figure out the scale factor? What do you think, Linda? 5 divided by 2. We're just figuring out how many times bigger 5 is than 2. So we just say 5 divided by 2 is 2.5. So the scale factor is 2.5. And we can check to see that we're multiplying our lengths by the scale factor. 2 times 2.5 as a check equals 5. So the 5-inch segment is 2.5 times longer than the 2-inch segment. So our scale factor is 2.5. We made it 2.5 times bigger, 2.5 times bigger. Questions? Okay. All right. Let me give you your homework. And our math boxes, I think I said our math boxes were going to be due on what would normally be our block day. Math boxes, since we have TCAPs this week, math boxes are going to be due on Thursday. So that normally is our block day, but it's not on the TCAP days. Math box 24 is going to be due on Thursday. This assignment will also be due on Thursday. And there you go.